So what's going on, guys? In this video we'll be seeing the basics of Windows 32-bit shellcoding, nothing too fancy. We'll be retrieving the ntdll base address using the assembly 32-bit MOSFET32 assembly. So before diving into the code, let's see what we're going to do using the Win32. So run the 32-bit version and open any 32-bit executable. So you can open Notepad from syswas 64. So there is a main function in the program in our binary. So type lm for loader modules, and you can see this is our program. So and you can see there is the main function. Let's put a breakpoint at that. So you can see there is a breakpoint. So let's go and run this one, and we have hit the breakpoint. Now in the FS register we will have some thread information, block information. So you can do like this: dd define double word or dump double word. Here D means display and the second D means D word. So display the contents at that address as the D word, and I am going to choose this FS. So this, in this segment we will have some thread information block structure which is used by the program's thread to access some information. So that is why the FS and GS are used in 64-bit. And you can see this is the you can type not tab. So this gives us the, you can see the values. These are in the continuous array. So you can see contiguous memory 12 ffc58 13,000 lakhs, something like that. So you can see from here you will have this juicy information pub address. So this is the 30 offset from the starting. So you can even calculate here. So the pub value is 105C, and so here you can see 105C, 4 bytes, 16 bytes, so 105C here, sorry, this is 105F. So this one is entire row is 16 bytes and 16 bytes and 16 bytes, so 48. So that is 30 in hexadecimal, and you can see the value we got is the pub address. So you can see the pub, not pub, and this gives us the pub at this 105C 1000. So this is the same value we got here. We can even cast this one. You can dt ntdll pub32. so make sure that you are using pub32, otherwise you will get some wrong values. And you can see being debugged. Yes, we attached the Win32 to the process, so it is being debugged and the field is set1. We can even override this field using the edit command. So we can say EB and the address and the value, and here you can see the LDR. So this loader structure contains the loaded modules information. So the first DLL that is loaded into the process is the ntdll, because user mode execution will be performed by the loader function in ntdll. So that loader function in ntdll uses the LDR functions inside the ntdll to initiate and start executes the process in the user mode. So that's why the ntdll is the first DLL. It will be loaded into the process, and afterwards kernel based DLL and kernel32.dll. So these three are the modules or DLLs you can find in a normal process when it started. Even when we do not import this kernel32.dll, it will be loaded into the our process. So this 105C1000 is the PEB, and from offset C we have this LDR. So DT I'm sorry, the actual LDR is the address, so we can paste the address here. We can see in load order module list, in memory order module list, and in initialization order module. So this is what we want, the third one, in initialization order module list. So the first one will be always ntdll. So you can directly click on this one, you will get the list entry. So the forwarding and backwarding, this is the double linked list. What you can do is you can cast this as you can reference this as LDR data table entry. LDR data table entry. So you can see the module information, and we will get some error because here you can see the in initialization order rings is the 10 offset from the starting of this LDR data table entry. So what this pointer does is it points to the next in initialization order rings of this LDR data table entry. So we need to subtract the offset from here. So you can see the 10 bytes, it is 16 bytes away from the starting. So if you want to parse this whole content as LDR data table entry, you need to subtract this 10. So we will be placed at this point, minus 0x10. Now you can see the full DLL name and the DLL name, ntdll. In the same way, you can forward the you can go to the F ring and say base DLL name, and that is kernel base.dll. And again go to the F link and this will be kernel32.dll, and there is no other DLL, because if you follow this one you will get to the starting point where we started the following the links. So we know that the first one is the ntdll. We need to retrieve the address of this. So let's go this one once again. And reading the 4 bytes, you will get the PEB base address, DT, and from this address, we can add 0C bytes to get the LDR pointer. You can read the 4 bytes from this 105C1000 plus C. You will read these bytes, so this address, and you can reference this as PEB LDR data structure. So let's do this. So let's move EAX comma so okay, let's currently our program will not compile because the WinDBG has the open the file. So and we also get some errors. So user register assumed to error, so we need to assume the FS as nothing because accessing these registers is treated as error. So now we are good to go. So you can see cannot open the file because we have opened that file in WinDBG. So that means we are not getting any other errors. Now EAX contains the PEB address. Now we need to add plus C to this address. So we can define a PEB base address. So we have stored the PEB base address in the PEB address variable, and we need to add plus C here. So add EAX comma 0CH. Adding 0xC gives pointer to LDR PEB. Now we need to read the 4 bytes from this EAX contents. So move EBX, and we need to copy 4 bytes. So we are going to cast this as dword pointer EAX. So whatever the contents in this EAX will be treated as the address. So EAX points to this 105C1000 plus C, which gives us the address of this contents. So we are going to read 4 bytes. So we will be reading this 7707 db100 db00. So now EBX contains this address. So let's from here onwards we need to add 1C to get the initialization order module list contents. So the contents will be 8 bytes, out of which first 4 bytes are F-link and the second 4 bytes are backlink. So forwarding and backwarding. So we need to add 1C here. So add EBX comma 1C. Now EBX is points to we are going to read again the 4 bytes from this address. So move, let's store this in EDX. We can even declare like LDR. Now we need to read 4 bytes again, EBX. So we have read these 4 bytes 1394020. Now we need to subtract these 10 hexadecimal bytes to get to the starting of this LDR data table entry. So let's try and compile. Okay, no errors. So now we have subtracted the 10 hexadecimal bytes from this address. Minus and from this address we have the DLL base address at 0x18 hexadecimal bytes. So we need to add 18 hexadecimal bytes. So we have added 18 hexadecimal bytes. So we can even get this, calculate this address. You can see the address here plus 0x18. So this gives us the ntdll base address. So we can verify this one. The value is 76F5000. Let's verify this one. You can see DLL base 76F5000. So we have added 18 and we need to read the 4 bytes. Move EAX comma. Now we are good to go. You can declare ntdll base and copy the ntdll base. Copy the EAX value which contains the ntdll base. So we are good to go. Let's close this one. Let's compile our binary, and we have successfully compiled. Let's put breakpoint at main function and run this, and you can see even the source code also got popped up because the PDB file is in the same directory of this exe. So our first instruction is copy the peb address into the EAX register. So if I type P, that is in step into, and EAX is currently some value, so let's step into this, and now the EAX is E8 8000. So let's verify that one. Peb, and you can see peb at E8 8000. The next thing is we will So the next thing will be, we will be adding 0ch. So we have copied the ex value into the peb base address variable, so we can verify that one. We can see the peb address value in E8 8000. Now we are adding C to the peb base address, which uses the pointer to LDR structure. So P, and you can see we have added C. And the next thing is, we are going to read the contents at that address. So let's DD, and you can see 7707 db100. We can type dt and t peb32, and let's say LDR, and you can see these are the same values. Now we are going to read the 4 bytes and place that into the EBX, and let's say P, and you can see EBX is pointing to this same value. Now we are adding 1 ch dt and t peb LDR data, and 1 C gives us the pointer to in initialization order module list, the address of that structure, and P. So EBX, we have added 1 C. So in initialization order module list, so the first 4 bytes are 138 40 20. So DD, and you can see we are reading 138 40 20. So the next instruction is kinda saving our value into the LDR variable. So let's skip that. Sorry, let's continue that. Now we are reading the 4 bytes at the EBX address into EDX. So now EDX should contain this 138 40 20. 138 40 20. Now let's subtract 10h, because we have already discussed that 10 hexadecimal bytes is offset from the starting of LDR data table entry. So we have subtracted 10 and we are adding. So let's and we can see the ntdll name and also DLL base. Now we are adding the 18 hexadecimal bytes to the EDX. Now we are reading the 4 bytes. So you can see 76 F5000. So let's P, and we can see EAX contains the ntdll base address. So we are storing that value in the ntdll base. So we have successfully retrieved the ntdll base address. So you can type lm to reach the modules, and you can see ntdll is starting at 76 F5000. So this is the basics of shell coding. There is one big problem with our code we have written, that it contains null bytes. So we'll be discussing how to remove the null bytes, doing some arithmetic calculations to overwrite convert these null bytes into some meaningful arithmetic operations, so that we will overcome the null bytes but having the same functionality. So let's go to the release. Let's go to the release. You can see the object file here. If I say object dump, disassemble, mode is Intel, and we get this disassembly of this our sections. We can see in the .text section our code, it contains our code, move ex, fs30 and all these instructions, and here you can see there are null bytes. So the null bytes is because this 30 value is, you can see the 30 is 4 bytes and it is taken like 0 0 1 2 3 bytes are 0 and fourth byte is 30 because the 30 is normally it takes only 1 byte to fill, so the remaining 3 bytes are pointing to null. So we'll be seeing how to do some calculations to like bitwise operations to overcome these null bytes. And here you can see again we are copying the value, so you can actually you don't need to store this pep address in any variables, so these null bytes will go off. So we'll be seeing that how to remove the null bytes in the upcoming videos. So that's all for the basics of shellcoding for now.